Welcome to the 6th video tutorial on percentage. In this video, we are going to be discussing about questions based on data interpretation. Now, without any further delay, let's begin with our tutorial. Now, data interpretation questions are a combination of problems based on percentage, mean, median, frequency distribution, etc. And you are asked 3 to 4 questions based on same data. For this video, I have picked questions from Manhattan 5LB, and all these questions require you to calculate percentage. But after we are done with lessons on mean, median, frequency distribution, then we are going to use the same data that tests our knowledge on these topics. Now, the trick to solve data interpretation questions is to look at the data before reading its questions. After you have understood the data well, it will become easier for you to solve the questions. Now, in this question, we have been given 2 graphs, one on the minimum temperature and the other on maximum temperature of 3 different towns. These graphs are represented by bar diagrams, and if we look at the horizontal side of the graphs, it is represented by months and the vertical side by the number of days. The gray bar is showing data of St. Louis, that is the temperature of St. Louis. The black bar of Winnemucca, and the white bar shows temperature of Galveston with respect to the month, right? Now we have 2 questions which have been solved in the next slide. In fact, next 2 slides, and so we're going to, I think it's better to go to the next slide so that we can understand the question and its answer well. Now, our first question says, approximately what percent of the days with maximum temperature of 90 degrees Fahrenheit or more in St. Louis occurred in July? Now, it's talking about the maximum temperature. So, we're going to look at the second graph, right? And if we look at the number of days that the temperature was 90 degrees Fahrenheit or more in July, in St. Louis, it is 15. And the total number of days with maximum temperature 90 degrees Fahrenheit or more is 44, right? Therefore, the question is asking 15 is what percent of 44? So you see the maximum temperature of 90 degrees Fahrenheit or more in St. Louis was for 44 days, out of which 15 in July we had maximum temperature of 90 degrees Fahrenheit or more for 15 days. So we are basically going to find 15 is what percent of 44. So what we're going to do is we're going to simply divide 15 by 44 and multiply it with 100 to get approximately 34%, which is our choice D, right? Okay, now our second question says that the number of freezing January days in Winnemucca was approximately what percent more than the number of freezing January days in St. Louis. And it further tells us that a freezing day is one in which the minimum temperature is 32 degrees Fahrenheit or less. Now, you see, look at the question. The question is asking us what percent more, which means that it is a percent change question. Secondly, it is asking us about 2 towns, the temperature of 2 towns in the month of January, and it is also giving us the description that 32 degrees Fahrenheit or less is the minimum temperature. So what we're going to do is we're going to look at the first graph only, and in that graph we're going to look at the month of January only, and in that month we're going to look at the temperatures of Winnemucca and St. Louis. Not just not the temperatures, but we're going to look at the number of days with minimum temperature of 32 degrees Fahrenheit or less. Right? So the number of freezing days in Winnemucca in January was 28, and the number of freezing days in St. Louis in January was 25. So what we're basically going to find is 28 is what percent more than 25, right? As mentioned in the question as well. So we will be using percent change formula, which is change or the difference divided by original into 100 the whole percent, right? So if we replace it by the values of original and change, we're going to get 12% as our answer. Now kindly note that in percentage questions, in percent change questions, if let's suppose you're confused, in what to pick as your original value, just look at the question. If it says what percent more, you're going to pick the minimum of the two as your original. And if it says what percent less, then you're going to pick the the maximum value of out of the two, right? Or out of the two values as your original value. And if it says percent change, that then you can use logic, because you see with practice you're going to well understand what the original value is and what the change value is. But I'm just giving you a tip on how to select the original value, right? Now the data for this question is also represented in a form of graph, and on the vertical side of this graph we have defective parts per 1000 manufactured by a machine operator, and on the horizontal side we have machine operator experience in hours, which starts from 0 to 16,000 hours, and the defective parts per 1000 are from 0 to 45. Minimum is 0, maximum is 45 defective parts per 1000. Now the question says that of the two individual machine operators who had a defective part rate of 4.2%, approximately how many hours of experience did the less experienced operator have? So basically we have two parts in this question. The first part is asking us for the defective part rate of 4.2%. And since we've been given defective parts per 1000, so 4.2% of 1000 is going to be 42, right? Very simple. Now there are two machine operators who had a defective part rate of 4.2%, right? If you look at the graph, we see that there are two machine operators who have a defective part rate of 4.2%. Now one is having a machine operator experience of less than 8,000 hours, right? As you can see in the graph. And the other has somewhere between 9,500 to 10,000 hours of experience. And the question is asking us how many hours of experience did the less experienced operator have. So obviously the less experienced operator would be the one who has less experience with respect to hours. So our answer would be less than 8,000, which is 7,700 hours, right? So our answer choice is going to be 7,700. You've understood? Good. This graph is a comparison of 3,000 students in 1950 with 3,000 students in the year 2000. Now the data is represented by bars, and what we have in the data is number of students on the vertical side and vertical side of the graph, and we have grade point average or GPA on the horizontal side of the graph. And the question and the gray bars are representing the students' performance in 1950, while the black bars are representing the students' performance in the year 2000. Now the question says that approximately what percent of the students in 1950 earned a grade point average less than 3, right? Very easy question. We only have to look at the gray bars, right? And the gray bars that are either greater than or equal to 3, or the gray bars that are less than or equal to 2.7. Simple. So going by the graph, less than 3 grade point average means students earning a GPA less than or equal to 2.7. Now, out of 3,000 students, 1,125 earned a GPA greater than or equal to 3, which means that 3,000 minus 1,125 is equal to 1,875, which is the number of students who earned a GPA less than or equal to 2.7, right? And to solve this question, we're simply going to do what? We're simply going to check 1875 is what percent of 3,000. Simple, right? So 1875 will be divided by 3,000 and multiplied by 100 to get the answer, which is 62.5%. And our answer choice is going to be D, which is 62.5%. Very easy question, right? Now with this, this was the last question of our video tutorial, right? Of our 6th video tutorial. With this, we conclude our lessons on the topic percentage. There are a total of 6 video tutorials on this topic. I hope you've understood them all well. Please watch it again and again if you don't seem to understand it. The concept is very easy. The questions are very easy. You only need to be a bit, careful in answering the question. That's about it all. I've told you all the tricks. I hope you've understood all the tips and tricks very well. Best of luck to you and goodbye for now. Thank you.